Hello guys, welcome to UNC virtual class. I am Prangyalin Sahoo, lecturer of Computer Science departments. Today I am going to discuss one of important core part of the ARM processor field, that's your addressing modes. So here is a table of contents which I will discuss and today one by one. So now to start the initial concept, what is addressing modes. Generally the addressing modes one of very important aspects of the instruction set architectures of the CPU designs. That means in case of instruction set architectures, there are number of addressing modes to be used. How all over the binary language to be given, all over the instruction of the operands to be specified. That means in case of addressing modes, how all over the operands that to be specified in between your instructions, that all over the things to be evaluated by using your addressing mode concept. In general way, if we express the addressing modes to be refers the way in which the operand of the instructions to be specified, that is to be called as addressing modes. In general case, the addressing mode also to be provides one type of rules or protocols if any changeable or any modification or any types of interpretations to be possibles in case of address field, that to be possibles by using your addressing modes. That means the addressing mode to be specifies one rules. If at the time of interpreting or modification of the address field to be necessary, to be required, so here that to be possible before the operand actual executions, that is to be called as addressing modes. Here there is many types of addressing modes to be available, but in case of ARM processors, here I have to define some basic addressing modes which are to be used for the CPU design in case of instruction architectures. So now to start one by one. So now to start the first addressing mode, that's your implied addressing modes. As we know, in case of instruction set architectures, which I will discuss on previous class already, in case of instructions, always the instruction to be consisting of two parts. One is of course, and the second one is that's your operands. The opcode to be specifies the operation code or the instructions, and the operand to be specifies whatever the raw data value through which the opcode to be operates. That means that is to be called as instructions. Here, whenever we have used the concept of implied addressing modes, here all over the operand data value that to be located under given instructions. That means in case of implied addressing modes, only that to be uses the particular opcodes, and through this opcodes all over the embedding operand codes, that value to be present in between your instructions. For examples, suppose in case of complementary accumulations, that means whenever we have used this given opcodes, here implicitly one of the data value that will be present in between your accumulators. Similarly, by using the given instructions, that's your instruction code manipulation accumulators, it also whenever we have to use this opcodes, automatically an implicit way one of the data value that will be present in between your accumulators, that already to be knew that by the processors, that is to be called as implied addressing modes. Now goes to the second addressing mode, that's your immediate addressing mode. In case of immediate addressing modes, here the data value that will be present in between your instructions on direct ways. That means in case of immediate addressing modes, for example, suppose you have to loading some data value from register R1, the data value is 100. That means here the 100 data value that to be immediately supplied through the register R1. That means directly you have to provide the given data value. In this case, there is no register to be alerted, and the hash symbols to be specified, that's your immediate data value, which is to be constant in nature. But it provides another types of facilities if the programmer to be necessary for changing the given data value repeatedly, that to be possible, so that in case of immediate addressing mode, that is very less flexible. But one of the advantages that to be occurs in case of immediate addressing modes, as the instruction to be directly specifies the given operand's data value, so it is very fast executions than the other addressing modes. Now goes to the next addressing mode, that's your direct addressing modes. In case of direct addressing modes, here the operand addresses that to be indicated directly. That means suppose for example in case of direct addressing modes, here one field that show instructions that to be contains two field, one is the opcodes and another one is the operand. Suppose here the operand is A. Here the operand address that to be directly mapping with the memory locations of where that to be stored. Suppose here the operand A value that to be stored. That means here the memory to be holds the direct address of the given operands. So that is to be called as direct addressing modes. And to take an examples in case of direct addressing modes. Suppose we have to rewriting the particular commands, of course that's your load, and writing the registers R1. After that writing another types of memory locations, that's of M of A. That means M of R1. That means here in case of direct addressing modes, all over the memory operands address value that to be directly accessed through the opcodes, given opcodes. That is to be called as direct addressing modes. Then goes to the indirect addressing modes. In case of indirect addressing modes, here the operand address that cannot be directly accessed on a given memory location for its manipulations. Here on intermediate positions that to be uses another types of locations which holds the actual operand address. That means for example in this case, suppose in this case here the instruction contains one operands that should A. Now when that to be mapping by using your indirect addressing modes, the address of the A that to be holds by using another types of operands. Okay, that means here the operand B that to be stored the address of the given operands, and after that the B address to be specifies the data value of the given operands. That means through the help of intermediate B elements we have to accessing all over the data value of the given operand A. So that in this case that to be uses indirect addressing modes. Whenever we have to representing all over the indirect addressing mode concept, in case of assembly code language that to be expressed by using your addressing symbols, suppose load R1, after that in this case we have used the @ symbols, after that suppose the data value is hundreds. That means here all over the data to be accessed on indirect ways through the help of intermediate any locations. Okay, that's your indirect addressing mode. Now goes to the register direct addressing mode. In case of register direct addressing modes, that to be similar nature as direct addressing mode. But in case of direct addressing modes, whenever we have to accessing all over the operand address the indirect way from given memory locations. But whenever we have to access any types of operands data value from the memory address location, in case of registers, in this case it uses the register elements. That means here all over the operand address that to be accessed directly through the help of one registers. That means here the instruction field to be consisting of two elements. One is opcodes and another one is the operands which holds the register name where the operand to be stored. Then after that register to be mapping with the register set locations where the given data value to be located. Suppose here the operand value to be stored. Then after that when that to be located the given register location, after that it to be accessing all over the data value. So here how all over this graphical notations to be expressed on the format of assembly code language. In this case suppose we have to representing one examples, that's your move R1 of R2. That means here the R2 is the operands where all over the data value that to be movable from the R1 locations. That's your register direct addressing modes. Now goes to the register indirect addressing modes. In case of register indirect addressing modes, whenever we have to accessing all over the operand address through the help of register, in this case it uses one type of intermediate registers which holds the actual operand register address. not the given value. And through the help of the actual register address by the intermediate registers, we have to accessing the actual register value. That means, for example, in this case, here suppose the instruction field that to be consisting two parts, one is the of course and another one is the register words. But whenever we have to needed for accessing all over the operand address data value, it to be goes to on a intermediate positions. That means here we have to use one type of intermediate location. Suppose here the register locations that to be contained, suppose R2. That means here the R1 address locations to be stored in between the location R2. After that, by using the addressing register R1 location through the help of R2, we goes to the next component part, that's your memory locations. And through this memory location, by using the address of the actual register address, we have to accessing the operand value. Here we have used the concept of the register indirect addressing modes. That means here how all over the graphical expressions to be represented on the format of textual or assembly code format. Suppose we have to rewriting the concept that here move R1 of R2. That means on indirect way you have to accessing all over the R1 operand data value through the help of memory. Okay, that's your register indirect addressing mode. Now goes to the next concept, that's your displacement addressing mode. In case, what is displacement addressing mode? In case of displacement addressing modes, generally it to be used whenever the instruction field that to be provides the address of the given operands and also the address of the index address of the given register where the operand value to be stored. In this case, we have used the displacement addressing modes. And how all over the addressing operand data to be accessed? In this case, when all over the register index base address that to be adding with the actual absolute address of the instructions, then whatever the effective address to be generated, by using this effective address, all over the operand value to be accessed. For examples, how in case of displacement addressing modes, all over the opcode, all over the operand address to be accessed. In case of displacement addressing mode, suppose here compulsory in this case the register index address to be given. The register index address to be given. Suppose here the index address that is your 20. After that, it also to be specified another address, that's your actual address or absolute address. Here the absolute address equal to 2. That means here the register to be contain some data elements, some operands data elements, and here suppose the data elements that show 20, 30, 40, 50. Okay. Now by using that operand elements, you have to calculate the index address. Suppose the index address of 20, that's your 1000, that's your 1001, 1002, 1003. But here in case of displacement and another elements that to be specified, that's your actual absolute value. Here the actual absolute value, that's your 2. That means when we have to calculate the actual operand address where all over the operand data value to be fetching, in this case that to be evaluated by using one formula, that's your effective address. Here effective address equal to whatever the register index address location value base value plus with the actual absolute value. That means here in case of 20, the index base address value, that's your 1000. Then the absolute value of the instructions, that's your 2. That means it provides the effective address, that's your 1002. Now the particular instructions code to be specifies the given locations, that's your 1002 in between your memory allocations. It to be accessed after that given location value. That means whatever the value to be stored in between your 1002 base locations, that operand to be fetches, and after that it to be performing its manipulation. That's to be called as displacement addressing modes. That means in a general term, in case of displacement addressing modes, here the instruction to be contains three fields. One is for the opcodes and the second one is the for the operands, that means whatever the registers, and the third field that we contains the absolute value, instruction absolute value, that means the address, that's your address. Okay. After that, whenever that to be fetching the operand address, here in case of displacement addressing mode, it to be calculated the effective address. The effective address to be calculated by using the register index address. So now we have to evaluate it and calculated the register index address. Suppose here the register set to be contains multiple number of general purpose registers. Now by using the general purpose register base address, it to be calculated the index address. After that, by adding the particular register index address with the actual address, then the effective address to be generated, and by using this effective address, it to be calculated the actual address where the operand to be stored in between your memory locations. After that, it fetching the given operand data value for its manipulation. That is to be called as displacement addressing modes. Now goes to the next concept, that's your stack addressing modes. As we very well knew that in case of stack addressing modes, whenever we have to manipulating any types of data elements by using your stack concept, the stack only provides one font space. That's your top of the stack. That means whenever we have to need for performing any types of data insertions or data deletions, that always to be possible by using your one font. That's your top of the stack. That means in case of stack addressing modes, whenever we have to performing any types of data manipulation, it only specifies one of the address location where the operand to be fetches, that's to be called as top of the stack. Okay. For example, in case of addition of two numbers, it requires two numbers. That means first we have to insert all over the data elements, one operands that to be stored on the top of the stack. After that, when we have to again loaded another types of particular operands, that's your V. Then after that we have to provide the plus symbols. That means now the particular stack concept to be pop out all over the operands like your A and V, and that to be concatenating with the opcodes plus, then performing the resultant outcomes, and that to be eliminated. So that in case of stack addressing modes, it always to be provides one address space where all over the execution, current execution data to be stored, that is to be called as top of the stack. Okay. Now goes to the next concept, that's your base offset plus addressing mode. The base of offset plus addressing mode to be specifies one base address that to be normally 16-bit in format. When we have to calculate it all over the particular operand address locations, here it to be normally use the register direct concept by using the offset address, whatever the 16-bit address to be specifies. But whenever the offset is 0, then it to be calculated by using your indirect register modes, as the specification already I have to explain. Then goes to the next concept, that's your base indexed offset plus addressing modes. In case of base indexed offset plus addressing modes, it to be provides two elements, whatever the base address of the given operands with is the index value. When the index value and also the physical address that to be added, after that whatever the generated outcomes to be provided by using this given address, we have to fetch the given data value. That is to be called as base indexed offset plus addressing mode. So this is all over the concept about the addressing modes and its types, generally that to be used in case of CPU designs. Whenever the instruction set architectures to be designed for the processors, how all over the particular operand to be specified in between your memory, that all over the specification easily to be evaluated, easily to be calculated by using your addressing mode concept. So if any doubt or any conflict in your mind, whatever I have to study on this class, then you can ask me by using your comment box. That's all. Thank you.